Okay, I am Mrs. Raposa, and I am going to be going over with you some notes about the unit circle. It would be a good idea if you had some paper out in front of you and you followed along as I go through. So we're actually going to start off doing some problems just to refresh our memory on what we did last class. So the first thing that I'm going to ask you guys to do is to draw an angle. So we want to draw an angle in standard position. So I'm just going to give us a bunch of angles and we're going to try to draw them in standard position. Here is our first one. Our first one is 210 degrees. So if I had to draw 210 degrees in standard position, I would draw myself an XY axis, and then I would start labeling. This is 0. Around to here is 180. Straight up here is 90. So I have 90, 180, 270, and a full circle is back around to 360. So to find 210, we always start here on the positive x-axis and rotate up and around, and 210 is going to be down here in the third quadrant. So that's how I would draw that one. Let's try problem number 2. Let's try a negative angle, maybe negative 355 degrees. So I'm still going to draw my XY axis. 0 still is over here on the right, but now since I have a negative angle, I rotate down, which makes straight down negative 90. Over here on the left, negative 180. Negative 270 is straight up, and negative 360 would have been a full circle. So let's draw our angle. Let's start on the positive x-axis and rotate down past negative 180, past negative 270, and negative 355. It actually would be a little bit closer, but as long as you're in the right quadrant, you are okay. Negative 355 would bring me to the first quadrant. So those were two angles that were in degrees. I want us to draw some that are in radians, because that's what we really need to get good at. We're going to be working a lot in radians in this class. So my first one is going to be 5 pi over 6. So I need to figure out where that one's going to be. So I'm going to draw my XY axis. 0 is still over here on the right. And we hopefully know from last class that pi is over here on the left. That's pi. It's 180 degrees. Well, because the angle that I gave you is 5 pi over 6, I'm going to, instead of call this pi, I'm going to call this 6 pi over 6. And therefore, halfway there would be 3 pi over 6. That's straight up in the air. Round to here is 6 pi over 6, 7, 8, 9 pi over 6. And a full circle would be 12 pi over 6, or 2 pi. So I'm looking for 5 pi over 6. So I start positive x-axis. I rotate around, and I'm going to stop right before I get to 6 pi over 6. It's right here. And that's where I would put, or that's where I would find 5 pi over 6. All right, let's draw another one in radians, number 4. Let's draw 5 pi over 3. Okay, so we always start off the same way. We're going to draw our XY axis. Here's 0. Around to here is pi, but because the angle I gave you was 5 pi over 3, we're going to call this, instead of pi, let's call it 3 pi over 3. Then I'm going to say, okay, halfway to 3 pi over 3, straight up in the air here, is 1.5 pi over 3. I know that looks funny because of the decimal there, but that was halfway to 3 pi over 3. So 1.5 pi over 3, 3 pi over 3, add 1.5 more, and we get 4.5 pi over 3. And if I add 1.5 more, 1.5 over 3, I get 6 pi over 3. So our goal is to find 5 pi over 3. Start at the positive x-axis, rotate around, pass 3 pi over 3, pass 4.5 pi over 3, and it's going to land us down here in the fourth quadrant, 5 pi over 3. So it's really important that we can figure out what quadrant we're supposed to be in when we're given an angle. So the next thing that we're going to do as part of a review is find the reference angle. So I'm going to give you a few angles, and our directions are find the reference angle. If I give you an angle in degrees, I want the reference angle in degrees. And if I give you an angle in radians, I want the reference angle in radians. So we'll start off in degrees. Let's start off with 335 degrees. Let's see where that one is. So to find my reference angle, I first want to figure out where I am. So here's my XY axis. Here's 0, 90, 180, 270, and 360. All right, so we start just like above. We're going to start at the positive x-axis. We're going to rotate around past 90, past 180, past 270, and 335 is down here. Okay, so then I have to figure out how far, well, to find my reference angle, I always go back to the x-axis. Even if the y-axis was closer, I have to go back to the x-axis. And my reference angle is this little angle that I'm highlighting that is in between the x-axis and our terminal side. And that angle, and I'm going to do it in degrees, would be the difference between 360 and 335, and that would be 25 degrees for my reference angle. Okay, let's try one more in degrees. Let's try 210 degrees. So we set up our XY axis. Here's 0, here's 180. And as you get better at these, you don't need to label all of these things that I'm labeling in black right now if you can just figure out where you're at. Since we're just starting out, I'm going to label them. So I'm going to start at the positive x-axis, past 90, past 180, and 210 would land me down here in the third quadrant. To find my reference angle, I always go back to the x-axis. Even if the y-axis is closer, I always go back to the x-axis. And the reference angle is this little angle that comes out of the origin, connects with the x-axis and my terminal side. And that angle that I highlighted is my reference angle. So we say, okay, what's the difference between 180 and 210? And that's going to be 30 degrees. So my reference angle is 30 degrees. Okay, let's try a few where we are in radians. Number 7. Go ahead and pause if you need to draw your pictures and make sure that you're getting a good understanding of this. Okay, let's try 2 pi over 3. So I draw my axis. I put 0 on there. I put pi, which is really 3 pi over 3. Halfway there would be up here, straight up, 1.5 pi over 3. So if I'm looking, that's enough of labeling. If I'm looking for 2 pi over 3, I start at the positive x-axis and I pass 1.5 and I stop right over here. That's 2 pi over 3. I drop a perpendicular line straight down to that x-axis. My reference angle is this angle coming out of the origin here. And that's my reference angle. So I would have to ask myself, okay, what is the, and I need it to be in radians. What is that distance between 2 pi over 3 and 3 pi over 3? And it is just pi over 3. Let's try number 8. This time I want us to try a negative angle. So let's try negative 5 pi over 6. Draw your XY axis. Here's 0. But because it's a negative angle, I'm going to rotate down. So if I rotate it around to here, it would be negative 6 pi over 6. Halfway there would be straight down, because remember, we're rotating in the negative direction. So negative 3 pi over 6, negative 6 pi over 6, and that's enough. I don't need to label anymore. I can now figure out where negative 5 pi over 6 is. Right here, before I would get to negative 6 pi over 6, I would find negative 5 pi over 6. Draw a perpendicular line back to the x-axis. My reference angle is going to be this angle inside that triangle right there. And it's going to be, what we have to ask ourselves, what is the difference between negative 6 pi over 6 and negative 5 pi over 6? And the answer is just pi over 6. Remember from last class, we said that reference angles have to be positive. All right, we'll try one more of these, number 9. And you might have noticed in the previous two problems that the original problem was over 3 and my reference angle was pi over 3. And my original problem was over 6 and my reference angle was pi over 6. That happens a lot, but not always. So I don't want you to think that that's always what's going to happen. So in number 9, I'll give you an instance when it does not happen. Let's do 7 pi over 12. All right, so XY axis. Here's 0. Here is 12 pi over 12. Halfway there would be straight up, which is 6 pi over 12. And that's enough labeling for me to see where 7 pi over 12 is. And it's going to land me here in this second quadrant. So I come back down to the x-axis. My reference angle is going to be this angle I'm highlighting in yellow. And then the question we ask ourselves is, what is the difference between 7 pi over 12 and 12 pi over 12? And the answer is 5 pi over 12 for my reference angle. Okay, so that was some practice with drawing our angles and practicing reference angles. I am also going to practice converting. So problem number 10, the directions are, I want you to convert from degrees over to radians. So we'll just try one of these. I'll give you an angle in degrees and I want you to give me the answer in radians. And the degree I'm going to give you is negative 150 degrees. So we have to remember the formula. To change this into radians, I'm going to multiply by pi over 180. And we'll see what we get. So one thing I noticed right away is a 0 on the top, a 0 on the bottom. Those guys can cross off. If I were to multiply straight across the top, I get negative 15 pi. Straight across the bottom, I get 18. And that can still reduce. 15 and 18 are both divisible by 3. So my final answer would be negative 5 pi over 6. And you always want to reduce as far as you can. Let's try the other way. So let's convert a problem from radians over to degrees now. And we can try 2 pi over 3. Let's use that one. So I'm giving you that in radians, and we've got to convert it over to degrees. So I'm going to multiply by 180 over pi. And the first thing I notice here is I see a pi on the top, a pi on the bottom. Those can slash out. I'm also noticing that I have a 3 on the bottom and a 180 on the top. 180 divided by 3 is 60. So now if I multiply straight across the top, I have 2 times 60, which is 120. And I have nothing left on the bottom, so my answer is going to be 120 degrees. Okay, the last review problem that we're going to do before we get into some new material is problem number 12, and the directions are find a positive and negative coterminal angle. So I'm going to give you an angle and I want you to find a coterminal. Remember, coterminal means that it starts and stops in the same spot. So the angle I'm going to give you, let's do just 5 degrees. And I want us to find a coterminal, a positive one and a negative one. So my rule is I can add or I can subtract a full circle to 5 degrees. Well, a full circle is 360 degrees. So if I do 5 plus 360, I get 365 degrees. And if I were to do 5 minus 360, I get negative 355 degrees. And those ones are my answers. Now, just as a refresher of what is that? What did we just do? Coterminals mean 5 degrees is right here. There's my 5 degree angle. A coterminal would start and stop in the same spot. So it would start here, but maybe I would go around a full circle and get back there. That would be 365 degrees. And if I did it in the negative direction, so if I started here and stopped here, that would be my negative 355. Notice they start and stop in the same exact direction. Okay, so we're going to take out those unit circles that we created last class. So you should have your unit circle nearby. At the very end of class last time, we were able to create these unit circles, and we talked about how all of the points on the unit circle are cosine of theta, sine of theta. And we remember that it goes in that order because C comes first in the alphabet. So cosine, comma, sine. So what we can do is if I said use your unit circle to answer this question. Use your unit circle to tell me what is the sine of 5 pi over 6. Here's how we'd do it. We'd come over on our unit circle and we would find 5 pi over 6. It's right over here on the second quadrant. And because sine is my y-coordinate, I would come over to my ordered pair and I see 1/2. The answer to my question is 1/2. So the sine of 5 pi over 6 is 1/2. Okay, let's try another one. Let's try the cosine of 7 pi over 4. So we need to find 7 pi over 4. So 7 pi over 4 is down here. And the cosine is represented by the x-coordinate. So my x-coordinate is a positive √2 over 2. So my answer is going to be √2 over 2. Let's do one more. You're going to want to keep your unit circle nearby. Number 3, let's try the sine of 4 pi over 3. Okay, the sine of 4 pi over 3. So we look at your unit circle, try to find 4 pi over 3. It's right here. Sine is my y-coordinate. And so my y-coordinate is negative the square root of 3 over 2. So my answer is going to be negative the square root of 3 over 2. All right, in pre-calculus, you are going to have a lot of questions that you'll come across all year, and again in calculus, that are like problems 1, 2, and 3. And the problem is, you're not always going to have this unit circle right next to you for you to look at. And that's a lot of information to memorize. Some of you will choose to memorize this and just pull everything off the unit circle. Others can use this shortcut method that I'm going to talk to you about. So how could we do that without the unit circle? Well, what we could do is we could make what's called a reference angle chart. And this chart is going to be like your lifeline to evaluating these guys. So when I set up my reference angle chart, just going to draw a big box for a chart. On the top left, I'm going to write degrees. Underneath there, I've got radians. And then I've got sine, cosine, and tan. I'm just going to set up my lines. All right, now what's going to go straight across on the top where we see degrees? What we're going to put is all of our angles starting from 0 and going through the first quadrant, all of our major angles on that unit circle. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, and can I squeeze 90? I'll put 90 out here. And my last one is 90 degrees. Now I have to know what those angles are in radians. So I'm going to convert them over, and then soon we should have these memorized. 0 degrees is 0 radians. 30 degrees is pi over 6. 45 is pi over 4. 60 is pi over 3. And 90 is pi over 2. Now, how I like to memorize these is a helpful tip, or something that may be helpful, is look at those denominators. They always go down in decreasing order. 6, there is no 5, but 6, 4, 3, 2. They always go in decreasing order. All right, now here comes my values. They're going to go in the rest of these spots. I'm going to put in a pattern as I do this, and if the pattern helps you, use it. If not, you can just memorize. In my first slot, I'm going to write the square root of 0 over 2, and I know that that can simplify. My next slot, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, the square root of 4 over 2. Hopefully you saw the pattern as I went through that. Now, anything that can reduce must be reduced. So in my first slot that says the square root of 0 over 2, the square root of 0 is 0, and 0 divided by 2 is still just 0. So there's a 0 right here. My next slot, which says the square root of 1 over 2. Well, the square root of 1 is just 1, so that's just going to be 1/2. My next slot, root 2 over 2 does not reduce. Root 3 over 2 does not reduce. And my last slot says the square root of 4, which is 2, divided by 2. Well, 2 divided by 2 is just 1. So my last slot is just 1. All right, that was the hard row to fill out. Once you've got sine filled out, cosine, we just write it in reverse order. So 1, root 3 over 2, root 2 over 2, 1/2, and 0. To get tangent, we have to know a formula here to help us get tangent. And for tangent, tangent is just sine divided by cosine. So since I know sine and I know cosine, I just divide them. 0 divided by 1 is just 0. Okay, I have to divide each one. 1/2 divided by root 3 over 2. Well, whenever you're dividing fractions like this, if the denominators are the same, they can slash out. And so what I'm left with is 1 over root 3, which I really don't like that radical in the denominator, so let's get rid of it. And I get root 3 over 3. Okay, next up, If I'm dividing my next one, square root of 2 over 2 divided by the square root of 2 over 2 is just 1. If I'm dividing my next one, the square root of 3 over 2 divided by 1/2, those 2 slash out, and I just have root 3 left. And last up, if I have 1 divided by 0, remember in math we're not allowed to divide by 0, that would be undefined. So this is my reference angle chart. I am going to need this. I'm going to use this. I want to keep this nearby. Throughout your class periods in the future, we're going to have you practice creating these guys. But this is going to be very helpful to us. All right, so instead of using the unit circle, we will use this reference angle chart along with something called All Students Take Calculus. So please draw an XY axis, and I would like for you to write in each quadrant up at the top, all students take calculus. And then into each quadrant, I want you to take a moment here and write sine, cosine, tangent in each quadrant. Let me make this a little bigger for you. Okay, so sine, cosine, tan. Take a minute and put that in every quadrant. Okay, now what the all students take calculus is, it tells you whether your answer is going to be positive or negative in a certain quadrant. So since all is in the first quadrant, what that means is that all of my trig terms are going to be positive in the first quadrant. In the second quadrant, I see the word students. Starts with an S, so does sine. So that tells me that sine is the only one that's going to be positive. My other ones are going to be negative. Okay, third quadrant is take. Starts with the T, so does tangent. That tells me that the tangent is the only one that's going to be positive. Sine and cosine are negative. And then last up, I have my fourth quadrant, which says calculus, begins with the letter C, as does cosine. Cosine is my only term that's going to be positive out of these three. Sine and tangent are negative. Okay, so what in the world does all this mean? Let's pretend like we don't have our reference angle chart in front of us. I'm sorry, we don't have our unit circle in front of us. I want you to evaluate the problems I put up here without using your unit circle. So turn your unit circle upside down when you're at home. Don't use it right now. We can only use the information that we have written right here, your reference angle chart, and all students take calculus. I want us to try to figure out what the sine of 7 pi over 6 is. Here's how we'd do it. We would figure out what quadrant we're in. So here's 0. Over here I find 6 pi over 6. By this point you may be able to say, oh, 7 pi over 6 is down here in the third quadrant. It's right past 6 pi over 6. Now, why do we care what quadrant it's in? Well, all students take calculus. We care because that's going to help us figure out if my answer is positive or negative. Since it landed in that quadrant with the T, only the tangent is positive. Therefore, my answer to this problem is going to be negative. I'll go ahead and throw a negative in front of my answer. The other thing I need to find is my reference angle. Well, this was 7 pi over 6. Back here is 6 pi over 6. My reference is pi over 6. That's a pi over 6 there. So to find my final answer to this problem, I go to my reference angle chart. I'm going to highlight on here. And I go to sine. So I'm going to sine. And I go to the reference angle of pi over 6. And I say, what value matches up with that? And the value that matches up with that is 1/2. So my answer is negative 1/2. Okay, I'm going to split my screen. I hope it doesn't get too small. Let's see. And just so that I have that reference angle chart in the All Students Calculus in front of me as we try a couple more examples. Problem number 2. I'm going to tell you that theta equals 2 pi over 3. And I want us to find the sine of theta, the cosine of theta, and the tangent of theta. Okay, don't use your reference angle chart. I'm sorry, don't use your unit circle. We are going to use our reference angle chart. So how do we do it? We're going to draw this. So let's draw an XY axis. Here's 0. Here's pi, or 3 pi over 3. So 2 pi over 3 is going to be right here in the second quadrant. Why do I care? All students take calculus. That S means that the sign is going to be the only thing that's positive. So I'm going to immediately put a negative in front of my cosine and my tangent answers. Then I'm going to come up with my reference angle. Well, this was 2 pi over 3. My reference angle is right here. The distance between 2 pi over 3 and 3 pi over 3 is pi over 3. So let's come back and let's look at that reference angle chart to come up with all my answers here. I will circle in purple. Reference angle is pi over 3. So I am looking here. And I can say for my final answer, just look down the chart right there, my sine is going to be the square root of 3 over 2. My cosine is going to be negative 1/2, and my tangent is going to be negative root 3. All right, let's try just one more problem. Problem 3. Theta equals, and let's try a negative angle, maybe negative pi over 4. Negative pi over 4. And I want us to do the same things that we did before. I want us to find, the sine of theta. Excuse my handwriting, guys. Cosine of theta and the tangent of theta. So I'm going to draw my XY axis, and I'm going to locate negative pi over 4. Now remember, if you have a negative angle, that means you rotate down. So if I rotate down, I'm just going to rotate straight down right here. And if you didn't know you were supposed to stop there, you could have said, okay, around to here is negative 4 pi over 4. Here is negative 2 pi over 4. Over 4. Therefore, negative 1 pi over 4 must be here. Now, why do we care where it is? All students take calculus. In that fourth quadrant, only the cosine is positive. So the sine is negative and the tangent is negative. We need our reference angle, and then we're going to get the answers. Our reference angle is pi over 4. So let's go to our chart. I'm out of colors. I'm going to use yellow again. And I'm going to look on my chart for pi over 4. So here's pi over 4, and I'm going to look straight down, and I can pull my answers. So the answer to the sine of negative pi over 4 would be root 2 over 2. The cosine would be positive root 2 over 2, and the tangent would be negative 1. So one thing I want to point out before we are finished is the negative that is right here only tells us that we're rotating down. That doesn't tell us if our answers are negative or if our answers are positive. That negative right there only tells us to rotate down to find our angle. Okay, we will practice this a lot more in class this week, but please, when you come to class this week, have with you this reference angle chart. You might also want to practice recreating a reference angle chart. See if you can make one and fill it in without looking at your notes.